Good afternoon, everyone. Last class we have discussed about properties of fluid. Next, continuously with that, we are going to discuss about viscosity. Viscosity is a important property resistant to flow. It's an important parameter. The resistance when your fluid is flowing, it's offering resistance called viscosity. For that, the important law, Newton law of viscosity is derived. It states that shear stress of a fluid layer is directly proportional to shear strain. Shear stress is generally denoted as tau. So tau equal to mu into du by dv. It is vary with it various types of fluids. Varies with various types of fluid. The various types of fluids are ideal fluid, real fluids, Newtonian fluids, non-Newtonian fluids, and ideal plastic fluids. Ideal fluids, which is incompressible and is having no viscosity, is known as ideal fluid. Real fluid. A real fluid which possesses viscosity as known as real fluids. All fluids in actual practice have real fluids. And next type is Newtonian fluid, a real fluid in which shear stress is directly proportional to shear strain. It is called Newtonian fluid, or in other case, in other way, we can say which obeys the Newton law of viscosity is called Newtonian. Non-Newtonian fluid. Next type, a real fluid in which stress is not proportional to the rate of shear strain, which does not obey the Newton law of viscosity. That is called non-Newtonian fluid. Next is ideal plastic fluid. Now we are in viscosity based on Newton law of viscosity. We are going to solve one problem. A plate of 0.025 mm distance from a fixed plate moves at 60 centimeter, requires a force of 2 Newton per unit area. That means 2 Newton per meter square. To maintain the speed, we have to determine the fluid viscosity between this place. Now we are going to solve in board for your better understanding. What is given data? Distance between the plates are given. It is 0.025 and velocity 60 centimeter. You have to convert the value into. Now I write given data. Given data. We can take it as distance between this plate as 0.025 mm. 0.25 mm. Or 0.025 mm into 10 power minus 3 meter. We are going to convert the value into 10 power minus 3. Next, this velocity is given in 60 centimeter per second. 60 centimeter per second or 0.6 meter per second. Converting the value into centimeter to meter. And force given is 2 Newton per meter square. Force given is 2 Newton per meter square. To find actual, they ask you to determine the dynamic viscosity. Dynamic viscosity is to find the dynamic viscosity. Going to determine. Dynamic viscosity is important property. It is mentioned as symbol mu. Symbol is mu. Called dynamic viscosity. We are going to apply Newton law of viscosity. Just now I explained Newton law of viscosity, which means Newton law of viscosity is nothing but shear stress is directly proportional to shear strain. So mu equal to du into dy. This is the formula we are going to apply. Shear stress. The value is force is given. So shear force tau is given. Du change in velocity. So change in velocity d is original velocity minus change in velocity. Then no change in velocity. That means 0.6 into minus 0 because 0.6 minus 0, 0.6. So change in velocity also 0.6 meter per second. Now we are going to substitute dy between distance is given. The value is 0.025 10 power minus 3. D is we have determined 0.6. Unknown time is mu. So substitute all the values the equation of viscosity. Sorry, 0. Okay. Now I substitute the value 2 into or 2 mu is the 2 fine. So I substitute mu as mu. Du value 0.6 divided by 0.6 divided by 0.025 into 10 power minus 3. So cross multiply to this value and divide 0.025 into 10 power minus 3 divided by 0.6. That will give mu value. So we solving this, put bracket in the calculator and multiply and divide the value, we will get the answer. So the final answer for mu is 8.33 into 10 power minus 5. 8.33 10 power minus 5 Newton second by meter square. This is the final answer of dynamic viscosity. Okay. Now we move on to next question. Basic sum here. Now application level problem for viscosity, fluid dynamic, corpus association manufacturing, high performance hydraulic fluids. For heavy machinery, a new batch of a specialized industrial hydraulic fluid has just been produced. According to the product specification, the fluid should have kinematic viscosity of 6 torques. Kinematic viscosity is given as 6 Stokes and specific gravity. Already last class we discussed about specific gravity. Specific gravity value is 1.9. Before this batch can be approved from shipment to clients, the quality control team needs to verify crucial property for its performance for various hydraulic systems. So, as a fluid engineer, mechanical engineer, they have to hydraulic engineer, they have to ensure the dynamic viscosity of the product fluid. So this they ask you to your auto task is to ask you to find out dynamic viscosity or it is often called absolute viscosity of this newly manufactured hydraulic fluid. Task is determine dynamic viscosity of this fluid. Determining dynamic viscosity is critical because it directly impacts the fluid resistance to shear flow, which affects because it's very important because it very affects how efficiently the hydraulic pumps operate. It's a critical vital role. The responsiveness of the machinery and wear and tear of components. The team needs to value ensure the fluid meets the requirement standards for lubrication power transmission. So as a hydraulic engineer, you have to ensure the pump operation is very smooth manner. For that, you have to determine the dynamic viscosity. Unlike last problem, we cannot able to apply in this problem internal viscosity. So what the based on the data, we have to determine the task is to determine dynamic viscosity. Now we can see how you can determine the dynamic viscosity. Let's see overall problem. So your task is determine what is the given, what are the given data in this problem. They are given only kinematic viscosity and specific gravity. Kinematic viscosity and specific gravity. So we need to determine two values. Okay. Given data in this logic, given data in this problem, given data. Given data is this problem is specific gravity only, specific gravity and kinetic viscosity. Kinematic viscosity. Kinematic viscosity is given and specific gravity. Kinematic viscosity, I take it as symbol mu Kb, and for the better understanding, K suffix V. Denoting kinematic viscosity is given as in this problem given as 6 strokes. Strokes is the unit of measuring kinematic viscosity, but we need to convert into meter per second as per standard SI unit. So 6 into 10 power minus 4 meter square by second. This is the kinematic viscosity we converted. For converting strokes into meter square per second, we have to multiply the value with 10 power minus 4. 10 power minus 4. Next exercise. So KV is right again. KV is equal to 6 into 10 power minus 4 meter square by 7. 10 power minus 4 meter square by 7. And specific gravity. Specific gravity, last class is already common. On properties of fluid, specific gravity is denoted as S. The value of specific gravity is given as 1.9. 1.9 to find. As here, engineer has to determine dynamic viscosity to ensure the smooth operations of hydraulic pumps. So dynamic viscosity symbol is, last class, the last problem itself, we denoted dynamic viscosity as mu. Now, what is the relation is used for between kinematic viscosity and dynamic viscosity? Dynamic viscosity Kv is often we are dividing density of a fluid. Kinematic viscosity, rho is density, mu is absolute viscosity or dynamic viscosity. So Kv is in generally dynamic viscosity mu divided by density of the fluid. It's important formula, already we derived. Now Kv value is available, density of fluid is not available. Density of fluid is not available. This is the proof. Mu is 2.5. So what are the data additionally given? Is directly given. Specific gravity of the fluid is given. Specific gravity of the fluid is given. Is called S. We have two relations specific gravity of fluid. First one is density of the fluid. We know specific gravity is density of the fluid divided by density of fluid, density of standard fluid. Standard fluid is water. Density of water. We know specific gravity is given. Density of water. Density of water is given 1000 kilogram by meter cube. 1000 kilogram meter cube. From that we can determine density of the fluid easily. It is called a rho. This rho is density of fluid. For better understanding, we can take it as density of water as rho W. Specific gravity as S. We can determine this density of fluid easily. And also specific gravity, another relation in terms of specific weight also we can express. Specific gravity is equal to specific weight of the fluid divided by specific weight of the standard fluid. Standard fluid is water. Specific weight is generally water is 9810. 9810 is specific weight of water. Okay. Now we can return substitute the values. What is the value of the specific gravity in this column? 1.9 equal to density of fluid. Rho is determining and viscosity. Rho divided by density of water. Density of water is 1000. Density of water is 1000. So rho equal to cross multiply with this values 1.9 into 1000. So the answer is 1900 kilogram by meter cube. The SI unit is kilogram by meter cube. Next, now we are find out the density and kinetic viscosity. To substitute the density value in the above expression, in this expression, you will get the final answer. Mu by rho. So kinetic viscosity is the value is 1610.4 minus 4 mu divided by 1900. The final answer is mu equal to multiply with this 6 into 10 to the power minus 4 divided by 1900. The final answer of mu is 1.14 Newton second by meter square. Newton second by meter square. Or in sometimes we can express the value in terms of poise. So for converting poise, we have to multiply the values into 10. So the answer is 11.40 poise. You can express the kinetic viscosity in poise also, but in general we are using Newton second by meter square. Okay. Next we will move on to another problem. This application oriented problem in a delta region of Nagapattinam. We are belongs to delta region of Nagapattinam. The agricultural machinery is being developed to improve the efficiency of oil-based hydraulic system used in field level operations. As part of the prototype testing, two square flat metal plates, each side measuring 60 cm, are used in a controlled test rig filled with oil, simulating real-time equipment movement through heavy viscous conditions. The space between the plates is filled with oil, having a film thickness of 12.5 mm. Having a film thickness of 12.5 mm. During testing, the upper plate is horizontally moved horizontally. Upper plate is moved horizontally at a uniform speed of 2.5 meter per second and a force of 98.1 Newton. To maintain this motion, the setup replicates the resistance experienced in multiple environments. Based on the testing cells, determine dynamic viscosity of the oil in poise. Last problem we mentioned determine the value in poise, because in some question they will ask how to determine the value in poise and the kinetic viscosity of oil in Stokes. If the specific gravity of oil is 0.95. Okay. So last problem, determine dynamic viscosity. But in this question, both the dynamic viscosity and kinetic viscosity not given. You have to apply the Newton law of viscosity to determine the dynamic viscosity, and then they are going to use a relation between the kinetic viscosity and dynamic viscosity. So now we can see, we can solve this problem. Yes, problem. Okay. Now we will move on to problem. Given data. Side of the plate is 60 centimeter. Side of the plate is 60 centimeter. So converting it to meter, 0.6 meter. The area equal to side into side 0.6 square. So what is the value of 0.6 square? 0.36. 0.6 into 6, 0.36. 0.6 into 6, 0.36 square, because we need area of the plate, 0.36 meter square, and distance between the two plates is 12.5 mm, is given in mm. So convert the mm into meter by multiplying it with 10 power minus 3, with 10 power minus 3, and then velocity is given as equal to 2.5 meter per second, and force is given. Force is equal to 98.1 Newton. This our task is to determine dynamic both the viscosities. First one is dynamic viscosity. Dynamic viscosity is solved to problems on dynamic viscosity. The symbol of dynamic viscosity is mu. Second property, important property is kinematic viscosity. Kinematic, both the viscosity you have to determine. Kinematic viscosities. So, unlike last problem, kinematic viscosity is not given. Km is also not given. Both the values are not given. We have to, what is the given data? The given data. What are the given data in this problem? Area given, distance given, velocity given. So we have to apply Newton law of viscosity. Newton law of viscosity, shear stress is directly proportional to du engine velocity into engine rate of spin. You have to apply. So mu is to find change in velocity. Velocity is given. So any they need not any, they didn't give any velocity changes. So d is equal to u minus 0. 2.5 meter per second is du. dy, the plate distance. When the distance is given, dy equal to 12.5 into 10 power minus 3. 10 power minus 3 meter. Tau, shear stress is not given, but they are given force and the area. We know shear stress is the ratio between the force and the area. So 98.1 divided by 0.36. So divide both the values. We will get shear stress tau answer 272. We are dividing, we will get the answer of 272.5 Newton by meter square. Next, substitute all the values in Newton law of viscosity. Say tau, we now just now written one. Excuse me. So tau du dy, substitute all the values in this equation, you will get the final answer of dynamic viscosity. So tau is equal to 272.5 means our final to find answer. So d equal to into du. 2.5 meter per second divided by dy 12.5 into 10 power minus 3. So cross multiply 272.5 into 12.5 into 10 power minus 3 and divide by 2.5. It will give the answer of mu. The mu answer will be 1.36. So I put bracket and multiply in the calculator 272.5 and 12.5 into 10 power minus 3 divided by 2.5. The answer will be 1.3635 Newton second by meter square. But they are asked the dynamic viscosity in question in poise. So poise means 1.3635 into 10. Answer is 13.635. So up to 3 digit will keep poise. This is the value of dynamic viscosity. Now second task is to determine kinematic viscosity Kb. So Kb we know this is the ratio of dynamic viscosity and the density of the fluid. Dynamic viscosity density of the fluid. Mu just now determined. To substitute the value in, but rho is not given. Like last problem, specific gravity is given. Specific gravity is of the oil or fluid is given. Specific gravity. We know specific gravity of the fluid is S equal to 0.95. So S equal to zero is equal to density of oil or volume itself explained. Density of the fluid or oil, what of fluid is given, divided by density of water. So substitute the values 0.95 is a specific gravity of value. Density of water, what is the value? 1000 kilogram by meter cube. By multiplying both the values, cross multiplying this, we can get the value 1000 into 0.95 or 0.95 into 1000 equal to 950 kilogram by meter cube. This is the value. Now to substitute the value in above equation, dynamic viscosity. So dynamic viscosity equal to viscosity equal to various things. And the viscosity second to mine is equal to mu divided by density of fluid. Mu were determined already. Substitute the value in Newton second per centimeter square. 1.3635 divided by 950. By dividing this, we will get the answer in meter square per second. 0.001435 meter square per second. At the final answer, they asked to determine the value in Stokes. For that, 0.01435 into 10 power 4. Ready, because we are multiplying the value, determine the value in Stokes, converting the value Stokes into meter square per second by multiplying 10 power minus 4. Now we have our job is to determine the value in Stokes. So for that, we have to the answer is in Stokes the value will be 143.5. 143.5 strokes multiplying into 10 power 4, you will get 143.4. So you will recheck the value 0.0. So this is the value we get. So next class we are going to discuss about pressure measurement. The value is 0.011435 meters square per second. Okay, thank you. I will end up the class. Next session we will discuss about measurement of pressure.